Good afternoon. This is another problem on describing data. This is page 60 of the note spiral, and this is an FRQ from 2006. So two parents have each built a toy catapult. In other words, they had to win the science fair for their kid because they didn't win when they were a kid, for use in a game at an elementary school fair. To play the game, students will attempt to launch ping pong balls from the catapults so that the balls land within a 5 centimeter band. So basically, their goal is to land in some sort of 5 centimeter band that looks like this. All right. A target line will be drawn through the middle of the band as shown in the figure below. All students on the target, all points on the target line are equidistant from the launch location. So you're going to launch from here, and the idea is this is the target line, but as long as you're within a 5 centimeter band, it's considered good. All right. So continuing along. If a ball lands within the shaded band, the student will win a prize. The parents have constructed the two catapults according to slightly different plans. They want to test these catapults before building additional ones. Under identical conditions, the parents launched 40 ping pong balls because they had a lot of time from each catapult and measure the distance that the ball travels before landing. Distances to the nearest centimeter are graphed in the dot plots below. So we have catapult A with the distribution that looks like this, and catapult B with the distribution that looks something like that. And the one thing that stands out to me more than anything else is both that catapult A is spread out substantially more than catapult B. So what stands out is catapult A is spread out more than catapult B. Other than that, they're reasonably symmetric. So it says comment on any similarities and any differences in the two distributions of distances traveled by the balls reached from catapult A and B. So as I said, it appears to me that they're reasonably symmetric in mound shape. And here's why I say that. I could kind of sort of fit a curve to that. All right. And then I can kind of sort of fit a curve to this. And I recognize they're not perfect, but real life data never is. And you're like, well, maybe there's something else, but it's reasonably symmetric. If I cut it in half, it's about the same. This one is obviously more spread out, and it has potential outliers on the upper and lower end. All right, so part A says comment on any similarities and differences in the two distributions of distances traveled by balls lands from catapult A and catapult B. So we talked about spread out, and we talked about shape, but we haven't talked about the center. Well, because we know that there are 40 balls. If I count, then my median is going to be half of that. So basically between 20 and 21. And I'm just going to let you know that I counted them out. For this one, the actual median is in that band. So 138 centimeters. And for this one, it's about 135 is what I think I wrote. But it's actually 136 when I actually physically counted them out, which doesn't take that long. Pause the. All right, so now I've switched over to what I actually wrote, and I said both are reasonably symmetric. However, the center of catapult B is higher at about 138 centimeters versus catapult A at 135, 136. Either one's close enough. The biggest difference is the variability in catapult A, or in other words, the spread, if you're more comfortable with that. In catapult A. Catapult A has both the longest and shortest shots, so it has the greatest range. Catapult A has possible outliers on both sides of the data. Catapult B does not appear to have any outliers. So we talked about the spread, we talked about the center, we talked about the shape, and we talked about unusual features. So we basically fully cussed that out, and that's what they asked us to do when it's a comment on any similarities. All right, part B says if the parents want to maximize the probability of having the ping pongs land within the band, which one of the two catapults, A or B, would be better to use than the others? Justify your choice. Well, for me, I look at this and I go, well, gosh, catapult A appears to be more variable. Catapult B is more precise. So because of the precision, I would choose catapult B. So because catapult B has less spread or less variability, I would choose catapult B. The smaller variability for catapult B would increase the probability of landing in a given band, assuming the catapult is placed at the right distance from the target. So assuming we place it at the right distance, we know better where catapult B is, whereas catapult A, we don't know where it's going to be. However, if you said which one's going to give me the best chance for the longest shot, I might choose catapult A. But catapult A definitely has more variability. So for part B, I would choose catapult B. Using the catapult that you chose in part B, and we chose catapult B, how many centimeters from the target line should this catapult be placed? Why would you choose this distance? Pause the recording. Okay, we said we chose catapult B, and I would definitely, and since we chose catapult B, the question is, where are we supposed to place this thing so we have the best chance of success? Placing at the median is a pretty good argument, so placing it at 138, but I can actually do a little bit better than that. I know that my target range is plus, if I hit within a 5 centimeter band, I'm good. So basically, if I go 2.5 centimeters above and 2.5 centimeters below, that's 5 centimeters. So I can go 1, 2, so about 140.5, all the way down to 1, 2, to about 35.5. And if I did that, I caught a whole lot of those ping pong balls. In fact, if I count the ones that I missed, I end up going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I missed 10 of the 40, and I got 30 of the 40. So 75% of the balls, ping pong balls, or 75% of my shots would land in a 5 centimeter band or land within a target band if I placed it at 138 centimeters. So in conclusion, for part C, I would place the catapult at 138 centimeters from the target. This happens to be the median value. At this distance, 75% of the ping pong balls landed within a 5 centimeter band, and that means I'm a winner, or my child will be a winner 75% of the time. Thank you, Stone Oak parents.